Welcome back. This is John with Vista Ascend Solutions, and I'm here to talk to you today about routing assertions. So in previous videos, we have referenced this model. This is the typical API gateway flow. We go from request, whether that's your user computer or another service, coming through a gateway to backend services. Now we keep the gateway in the middle here, typically in the DMZ, to ensure that the security is maintained to these backend services. Typically these services can only be accessed by the API gateway. Coming through, we've already talked about how to access various policy endpoints on your gateway, but we haven't really talked about what that means to routing to backend services. And so when we created our policy logic, we kind of did this a little bit. So in our previous video, we had a couple responses, and if you remember, we had some terms that we were outputting, variable instantiation and the variable output. So you can use this terminology to output variables. And what we kind of glossed over was that this is acting as a service. So this is generating a response, something we would get back from our backend service and returning that through. So in a way, the API gateway is kind of mocking out this service to begin with. But as we grow and build our API gateway knowledge, that is not always going to be the case. We're not always going to have a little assertion that can send out whatever we need it to. We're going to have other services that we need to react and adapt to. And that's what we're going to show you today. So one real quick thing before I start is I have done a little housekeeping. So all of my YouTube content is now in a YouTube folder, which is sitting on my gateway. And so we're going to have a little bit better bookkeeping in the future. So let's start by exploring a little bit on what we want to expose. In a typical production environment, you are going to have services. You are going to have some sort of response that is being given by these services. Hopefully it's RESTful, but not always. So we'll go to one of my old friends at webcomics, Dan Wendorf. Thanks for letting me use your stuff. We're going to go to shapes.keenspace.com. Now this is a webcomic from back in 2004, so it's a little over 21 years old now. It was made a long time ago, but we can still use this. And so we're picking this for a couple specific reasons. The main reason is that it's pretty low in terms of complexity. There's not a lot going on. We can bring up the developer console, specifically the network. We can see there's a lot of pages coming in, but it's mostly JavaScript, maybe a little CSS, but then here's the meat, which are these image files that are representing the comics. And so we're going to proxy this. So we see right here, we've got an address, shapes.keenspace.com. We're just going to copy that off. And then in our YouTube folder, we're going to create a web API. I did that by right-clicking the folder and going to publish web API. You can also do that if you went to home and publish web API. You just have to remember to put the policy in a folder when you're done. So for ease of use, right-click is what I'm going to be doing. And we're going to call this shapes. And we're going to have this resolve to shapes. So before we get anywhere, let's double check that this policy doesn't already exist. Yep, we're getting our 404. This is in our catch-all. We're off to the races. So let's do shapes. We're not going to have any wildcards. We'll talk about that in a second. And so we've got our shapes endpoint. Let's just make sure that we get 0 response or a blank response, which is indicative of having an endpoint that's not sending any data back. So now we're going to go in, and I've already got this queued up. We're going to type in route into our assertion list, and you'll see there are a bunch of routing assertions here. The ones you will probably be using is the HTTP or HTTPS, and FTP, FTPS. You'll see Layer 7 also has support for HTTP2, JMS, Kafka, any sort of message query, if that's Rabbit or Active or however you want to have your message bus, as well as raw TCP. There are mechanisms in place to extend and add to these. This is what comes out of the gate. So you should be able to see all of these if you are running Layer 7 API Gateway 11.1. For today, since we're exposing web pages, we're going to route via HTTP. And so we'll come in here, and we have already copied that URL, makes it a little easier. We're going to save and activate. There are no comics, so that's a little disappointing. So this is where we start analyzing our APIs. This is where we start determining what other APIs need to have, if any. So let's refresh this again so we can see all of those URLs that we're trying to load. And immediately I'm going to go to my image files, because that's the webcomic, right? So let's bring this out, and we will see one of the largest considerations you have to make when incorporating an API gateway. In this use case, the API gateway is being used as a reverse proxy. So when we're talking about reverse proxies, there is some sort of additional path that gets added into. This is not a blind proxy or something that is a relatively transparent or seamless pass-through. It's not going to work like an ingress controller, but it might work similar to an ingress controller based on your implementation. But right here, we can see the culprit. So the request URL, which almost guaranteed came from the base HTML page, is a reference to image libraries. Makes sense. It's a webcomic. And so we see we've got this request for HTTPS, our API gateway URL /comics/shapes, and we don't have a path for that. And so what we're getting in our response is nothing, which is not what we want to have happen. Now, if there are other files that are also not being resolved, we might get the Vistas and Solutions catch-all endpoint. We might get various errors based on the content type it's requesting. A lot of different options here. But we can see there is empty response where there should be an image. And we're going to a URL we don't have. So I've been stalling this whole time because I'm hoping you all are thinking of a way that we can incorporate this comic path into policy. And you might be already ahead of me. So what we're going to do is we're going to add to this gateway another service endpoint. And we're going to call it shapes comics /star. So this is the wildcard we were talking about before, where it's going to match anything after this path. So we're going to bring that in, simple finish. So now we should be resolving these image libraries. Let's do a refresh. Oh, we forgot to put in a routing assertion. Okay. So we're going to put in a routing assertion, but how do we make something generic enough to figure out what we're routing to? But how do we make something generic enough to handle multiple use cases, but specific enough so we don't pick up too many use cases? And so we're going to use a little bit of a strategy here. So the API gateway expresses this entire path, the entire URL, as various request variables. So the request variables themselves can be used as the entire URI, just the domain, or a path, or a part of a path. There's a lot of things we haven't talked about when it comes to manipulating variables and figuring out different parts of the URL you're trying to get. So for today, we're going to make this a little easier. We're going to bring this in. This is going back to shapes keen space com, and I'm going to give you guys the easy button. So we are going to reference a variable in here. So we've requested a variable in here. It's the request URL path. Now I'll tell you right now, that's going to take everything after the comics endpoint and insert that. So what we've essentially done here is taken a routing assertion and allowed any user, any request that's coming through that shapes comics endpoint, the ability to create a generic path forward. So we've got this, we've saved and activated it, and immediately we can see some different results. Here we are, we have our webcomic. Thanks to Dan Wendorf for creating this webcomic so we could use it today, 21 years later. So this is probably one of the easier solutions to proxying services. Now you'll notice this is still fairly open, where if there was another service in our diagram that was also using a comics endpoint, we'd be a little out of luck here because we wouldn't know which service to resolve. We wouldn't know if this should be going to test 1, we don't know if this should be going to test 2. And so when you're creating these routing strategies, it's important to understand the ecosystem that you're deploying into, so you can properly protect and allow various endpoints. So we're going to leave these up here for now. We're going to move to another page, and this is a page I tend to use for network validation, to make sure that certificates are right, to make sure that we are able to connect to resources. And it is one of my favorite websites from 1999, and that is Zombocom. So today we're really taking it old school. So Zombocom is really just a splash page, and it's going to do this forever. There is an audio that comes in that says things over and over again. So it is a great representation of loading a website, loading CSS, loading images, and loading MP3s or audio. We're going to do that today too. You get a double one. So let's talk about building another API, and this is Zombo. So Zombo is going to start very similarly to how we started our shapes webcomic. So let's get rid of these so we're not cluttering up anything. And so we're going to start by creating a routing assertion. And this is going to go to Zombocom. We're going to save and activate, and we're going to give this one a shot. So right away, Zombocom. Okay, we've got something, but this is not looking very similar. Not at all. So it looks like we got some broken images. It looks like we have some semblance of audio, but I don't think it's loading. So let's look at our network tab again. So far fewer resources being used than our webcomic, but you see we have some unique ones. So we've got different CSS, we've got image files, we've got MP3 files, we've even got some fonts that are getting loaded in. And immediately you can start looking at some responses and see what works and what doesn't. So the main URL seems to work. These are all references to files that are probably brought in from this HTML file. It looks like we have a good font awesome, so that's great. That always makes things a little easier. Oh, okay, so here's our first issue. So it looks like we are routing to our catch-all, which means we have a path that is being requested on the gateway that we don't have a great response to. So let's look at this. So right now we can see we have a Zombo CSS file. So in this website, it is probably making a relative path to Zombo CSS. Okay, let's make a note of that, see if we can figure some stuff out later. We also have some blank images. So these are those broken images we saw before. Now it looks like there's an images folder that's on the Zombo domain that's bringing in these images. So I see a ZomboCom image in the images directory, I see a PNG wheel in the images directory, and it looks like that's the only main images. Now we also have an MP3 file that is also getting removed from our gateway. And that is no folder, just Zombo words MP3. We've got a little bit of work to do here. Let's tackle the CSS first, since that's going to be the easiest one to test and validate. So we're trying to go to Zombo CSS. Okay, let's make another web API. It's going to feature a little bit more information here. We're going to call it Zombo Star. So this will be a different path or different service endpoint than just pure Zombo, because this is also going to have that wildcard. So this should match Zombo CSS. It should also match Zombo words, right? Because there's something after that wildcard. So this will match Zombo words this will match the Zombo wildcard instead of just pure Zombo. So we're going to bring some stuff over. I'm going to copy this assertion, since we can copy and paste. We're going to paste it in here, and we're going to change this URL to be what we had with our webcomic URL. So this is going to be request URL path. We'll save and activate, and hopefully what we see is a little bit closer. And okay, we're getting better. We're getting better. So now we still have our broken images, but it looks like our CSS loaded. So we'll see this is very similar to what we were seeing over here. We're even seeing the image spinning, so we understand that there's some HTML5 being done behind the scenes here. I should note that this site was originally developed in Flash, so after I think 2021, they had to rechange their endpoint. Okay, we're getting closer. Let's look at the network tab one more time. So we do see that we have good CSS, so we did solve that. We did get Zombo words, so that MP3 file is coming back, but we won't see the response because it's not something that can be expressed in words or even hex at that point. So let's look at getting these images, because that's going to be our next issue. So we have this images folder, and that comes for ZomboCom PNG and PNG wheel PNG, as also Zombo BG PNG. So everything's present in the images folder. So there are two ways we can do this. We can do this like we did for the comics, and just create an images directory. So that service endpoint will relate everything, or will match to this Zombo images service that we're set up. And we can even go so far as to straight copy and paste everything we got from our Zombo wildcard. And this should work. That looks pretty similar to me. So in this way, we have the ability to easily reverse proxy even existing websites, even websites that we don't own. So when we look at services, the way that these services are laid out in this kind of network topology diagram is that they are internal to our network. But as you've seen here, they don't have to be. They can be external, they can be sending up text or images or audio or anything. And we have the ability to proxy these through Layer 7. Now the last thing I wanted to mention is the just because you can, should you. So we have a /comics. For a service, you're probably not going to find too many endpoints that have a comics folder or comics prefix. So this is a little bit less dangerous. But if you're going to reverse proxy a website that has an images folder, and let's say that that images folder exists on service 1 and service 2 and service 3, you have a conflict. So there's a couple ways you can handle this. What I would recommend is if you own the service, to implement something that's going to tell the server what they should be referencing. And so what we typically see through proxy servers is the ability to use an X-forwarded prefix. And so your bonus lesson for the day is managing those headers. So when we look at headers, this is the manage transport properties and headers. We have the ability to modify several different things, but since we're dealing in HTTP, we're going to deal with HTTP headers. You also have the ability to add a replace, or remove. And so we're going to choose add or replace, as it's one of the safer operations. You can add, however, if there is already an existing header with this value, or with any value, it will comma separate in addition to that. So you could have multiple headers, you could have headers that have multiple references, multiple values, and it becomes a little bit dangerous. So I always recommend using an add or replace. And the header that we would want to be using is the X-forwarded for header. Now we use the X-forwarded for header as a temporary in-place header if you manage or maintain these services. If these are exposed through an ingress controller, this will be much easier. As ingress controllers, specifically Nginx, will be able to support the X-forwarded for header and ensure that you are getting the right values back. And then we can say this is /images. So let's put this into the request instead. So we're going to right click, select target message, put this on the request. And so why would we use X-forwarded for? In a proxy situation, you are going to have additional path that you wouldn't necessarily have. So we saw this with images, we saw this with comics, we even saw this when we started building out Zombo and shapes. You create the X-forwarded for header to tell the backend service where, not only where are you coming from, but also how to modify any requests that are coming into this path. So for instance, if we wanted to say, all right, everything's got to come through the /Zombo wildcard. So this will be the Zombo support. If there is a Zombo index, if there's a Zombo images, if there's a Zombo background, you want to be able to ensure that everything's coming through one endpoint, and this X-forwarded for ensures that any websites that are being served up are going to use the appropriate prefix. So it gives you a lot more flexibility in reducing the number of endpoints you have, It increases your ability to maintain, so it decreases your maintenance costs. The downside is it's not supported by everyone. So check your browser, check your web services, ensure that they can support X404, and if not, you just have a little bit extra work to make sure that this reverse proxy is serving up everything appropriately. All right, that was everything I wanted to talk to you about today. I appreciate the time. Thanks for listening. If you have any questions, feel free to put them in the comment section. Give a like and subscribe, and thanks for watching.